Consider two isosceles prisms 1 and 2 with prism angles A1 and A2 and refractive indices N1 and N2, respectively. The faces are parallel to each other and perpendicular to the mirror M. If a ray of light is incident on the first prism and emerges from the second, then the correct statements are: Option A. If both prisms are at minimum deviation, the ratio of N2 to N1 equals sin A1 over 2 divided by sin A2 over 2. Option B. If prism 2 is at minimum deviation, sin I1 equals N2 sin A2 over 2. Option C. If both are thin and at minimum deviation, theta equals delta M1 over 2 times N1 minus 1 plus delta M2 over 2 times N2 minus 1. Option D. If prism 1 is at minimum deviation, sin I2 equals N1 sin A1 over 2. Let's analyze the setup. Because the inner faces of the prisms are parallel to each other and perpendicular to the mirror, the angle of emergence from prism 1, E1, is exactly equal to the angle of incidence on prism 2, I2. For option D, if prism 1 is at minimum deviation, the angle of incidence I1 equals the angle of emergence E1. By symmetry, E1 equals I2, so I1 equals I2. Substituting this into the minimum deviation formula gives sin I2 equals N1 sin A1 over 2. Thus option D is correct. For option A, if both prisms are at minimum deviation, we also have sin I2 equals N2 sin A2 over 2. Equating the two expressions gives the ratio N2 over N1. So option A is correct. However, if only prism 2 is at minimum deviation, I1 does not necessarily equal E1, making option B incorrect. Finally, for option C, if both prisms are thin, the deviation is n-1 times A. From the geometry of the setup, the angle theta between the incident and emergent rays is half the sum of the prism angles. Substituting the expressions for A1 and A2 confirms that option C is also correct. Therefore, the correct statements are A, C, and D.